Okay, in this video, let's take a look at another example of a Venn diagram. This time I've included a universal negative and a universal affirmative. So there's no sum in this one. And, you know, my advice to you when you draw those two is to draw the universals first. Since they're both universal, it doesn't matter here. I don't have a conclusion here. I want to see if we can come up with a conclusion. Alright, based on what we see in the drawing. So let's draw the first one first. No A is B. Remember, since these are the only terms involved, we can pretend the C is not even there. There's no A is B. So you see those two. When I say no, I mean I've got to close off the space in which those two circles overlap. Because if I leave this space open right in here, potentially you can have an A. All you need to put is an X in there. That is also a B. So the fact that I don't have any X in here does not mean that, okay, well, there's nothing in there, so no A is B. That's already drawn. No. You got to exclude the possibility of even an X ever appearing in that space. So no A is B means that we come in here, right in here, and we close this off. So that if ever there is going to be an A, a little X we place, we cannot place it in that space. Now we can place it here, 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 here. Any of these spaces is free of the B circle. So no A is B is represented graphically here accurately. Now it says all C is B. Okay, that means if there's going to be a C, it has to also be in the B circle. So that means I got to close off this space. Okay, this cannot be open space. And in doing this, you see that everything that's left of the C circle now is going to be inside the B circle, which is what you need if you're going to say all C is B. Notice that's not the same as saying all B is C. So if all C is B, then we got that C part inside the larger B. Now what also has shown up? The fact that there is no C in A or A in C. So we can say this. No, A is C. You see, because in drawing these two, as I did, I've also managed to draw this right here. You see this overlap? That overlap has been completely closed off too. So, when I drew these two, I stick that on there. Can I say to myself, has that already been drawn? Yes. In drawing these two, this one gets drawn. So this is valid. Now let me take the opportunity here to talk to you about some interesting qualities about these statements up here. If no A is B, then it's also true that no B is A. So no A is B equals no B is A. That's an interesting thing you can do with a universal negative. Okay, you can flip the terms around inside the proposition, it doesn't matter. But you can never do that with a universal affirmative. All C is B. Did I draw that correctly? Yes, see? That does not equal all B is C. You see how that doesn't equal that? So you cannot switch out these terms in a universal affirmative, but you can do it in a universal negative. So no A is C also equals no C is A. See that? They're excluded from each other, so you can do that flipping out. That's part of immediate inference also. So anyway, we find out this is a valid syllogism. It would have its own Latin name. I can't remember it, but we may come up with a list for that. Anyway, on to the next one.